In this video, I'm going to demonstrate a suite of tools for drawing and exploring organic structures. All the tools were designed to be easy to use by students so that they can focus more on the concepts and less on how to use the tool. First up, we have a drawing tool, and we have a prompt that asks us to draw 3-phenylpropanoic acid. So we can start by clicking and dragging a benzene ring into our play space, and then we can quickly add a carbon chain just by dragging from one of the carbons on the ring and continuing to build out our chain here. To add heteroatoms, there's a couple different options. We can extend the chain and then drag and drop to replace that last carbon with an oxygen, or we can select the oxygen atom and then we can drag and we can drag again to form a double bond and add in that carbonyl group. All of these interactives are accessible, so we can check student work to see that they've done it correctly. Now let's say, though, you wanted them to draw the carboxylate anion. There's a couple of different ways you can do that. When you select an atom in the structure, the atom menu appears. And from here, you can change the charge to a negative charge, or you could expand out that hydrogen, select it, delete it, but the student is still in charge of adding in that minus label. Another thing you can do with the atom menu is show and hide implied lone pairs. If we select a carbon, now we can show and hide implied hydrogen atoms as well. Next are the projection tools. So here we have a Newman projection template, and we're going to work on generating the lowest energy conformation of 1,2-dichloroethane. So we can click and drag these labels into these boxes, or we can click and hold down Shift to select multiple boxes with the same thing. And once our Newman projection is complete, we can pop it out into 3D, and we see a 3D model that is looking with the exact same perspective as shown in the Newman projection. But when you click and drag in white space, you can go ahead and rotate that model as well. And again, these are all accessible. All right, now let's give the highest energy conformation. So again, we're gonna drag and drop our labels on here, and then let's quickly hold Shift, select all of these and replace with hydrogen. And now we need to get it into the eclipse conformation, so we can click and drag on a group to spin either the front or the back carbon, and then once again we can pop it out in 3D and see that yes, they are eclipsed as well. All right, next we have a chair template, and you can see the positions, those axial and equatorial positions, by clicking on a carbon, and then we can replace the H's in those boxes with the desired group. So we want the more stable chair conformation. Methyl can go in the axial, whereas we want to make sure that T-butyl is in the equatorial. And if you don't want to see those hydrogens, you can click the carbon again to hide them. All right, last we have our Fischer projection here. Right now we have one chiral carbon shown, but up here we need to convert this bond line drawing, and there are 3 chiral carbons. So we can quickly add to the template by pressing the plus button, and then once again we can drag and drop our groups such as our aldehyde and then our OH groups as well. And the dash flying underneath with the head at top, that OH is going to be on the left, and again you can select holding Shift and replace multiple with the same atom at once. And then let's go ahead and finish off our projection. And this as well, you can generate a 3D model that you can go ahead and rotate and compare with what is shown in the dash wedge drawing here and check your work. All right, let's go back to the drawing tool. So this is a tool you would also use with questions such as predict the product. So here we have a bromination reaction, and the student is given the starting material to start with. They can go ahead and select the double bond, and that will bring up the bond menu, so they can switch it to a single bond. And then we can go ahead and add in our 2 bromine atoms. So we can hold Shift to select those 2 carbons and then select bromine. But the prompt reminds us to consider that stereochemistry. So again, you can select a bond and you can switch it to a dash and a wedge because we have anti-addition. You can also double click on a molecule and Control C and Control V to create a copy of the molecule. and you can move it around too once it's selected. You can also change the bonds using hotkeys, so I can hit D for dash and W for wedge, and now we have both enantiomers of our racemic mixture. Last but not least is our mechanisms interactive. So the example we've chosen is an acid catalyzed hydration reaction, and below it is the mechanisms tool. So in the gray box at the top is where we're going to be building our final answer, box by box, and down below is the workspace where you actually draw your arrows and edit the structure. So first we have the arrow tool is automatically selected for drawing curved arrows. So first thing we're going to do is go ahead and draw those curved arrows, which are lively and respond to the mouse, so you don't have to choose the arrow with the correct curvature. And once we're satisfied with the arrows we have, we click the update button because we want to update the image that was in that box with our curved arrows. And now the next step is to edit the structure as the arrows indicate, and it automatically switches over to the edit structure tool. So I can go ahead and I can change that to a single bond, put in our carbocation. I can move that charge label to a more pleasing location, and then also this is no longer positive because it donated that proton. All right, so now that we're done editing the structure, I'm going to go up here and turn on curved arrow mode, and I'm going to draw that curved arrow from the lone pair to the carbocation for that intramolecular attack. And now I'm satisfied with my drawing, so I'm going to go ahead and update my final answer. And now again, edit structure, and this is the really fun part. I don't need to delete this whole thing and then drag in a 5-membered ring. I just need to go ahead and add a bond between that oxygen and carbon, adjust this a little bit so it looks a little better, and update the charge on that oxygen as well. I'm going to go ahead and pop out that hydrogen since we need to do a proton transfer for that last step. Now let's go ahead and move this over here, because if I was drawing this on paper, I'd want my water over here to do that proton transfer. Again, draw a curved arrow from that lone pair to the hydrogen, and now break that bond, and let's go ahead and update. And in this last frame, all we need to do is edit our structures to reflect that last set of arrows. And we're going to update again. And now, so that you can easily review your work and see what you've done, you can go ahead and expand this into full screen mode. And now we can see our full mechanism, and we're feeling pretty good about it. So let's go ahead and check our answer. And yes, indeed, we are correct.
All of these learning tools and future ones are designed to be accessible for all students, including those who are blind or have low vision.